Okay, let's get started on the class. I'm sorry, I had a little technical trouble this morning. Um, First question is anything about the homework that people want to discuss? The homework is due on Thursday, on Tuesday, correct? And are there any questions that are outstanding? There's been a fair amount of discussion on the piazza. There's been a certain amount of small changes to the homework, okay, which intended as simplifications. So if you want, make sure you check the original assignment and check back on piazza. Any questions about the homework? Okay, anyone? Any interesting observations about this data set? You've got this data set about stores that you're working on. Anything worth chatting about, either here or in TV land? Okay. The second issue is about the project proposal, and there has been a certain amount of begging on the thing to delay the progress for project proposal. I'm not going to do it, but I wanted to explain why. Recognize that the project proposal is just a proposal. It counts for 6% of your grade. It's supposed to be about getting you started on something. What I need from the project proposal is I need you to know what you're going to do. I need you to sort of have done enough little looking to believe that you can do it. Okay? So it's important that the proposal, the project proposals come in. It's important that they get looked at quickly enough to be turned around to help you with actually doing your project. Because shortly afterwards is a progress report, and shortly afterwards is the end of the semester. So I'm afraid I can't delay the project proposals. I'm very happy to talk here about the project things. So if people have questions about the project things, I'd like to discuss it. But again, it looked like from the data that was displayed, most people are working in three people groups, which is fine. Um, there was a breakdown of the projects that people had chosen, which I guess many of you have seen on Piazza. And the thing that I notice is that of the four most popular slots, okay, none of them were the projects I thought best. Okay, that doesn't mean that they're bad. If you're doing that and you're interested in it, do that good. But recognize that some of the other projects are also very good. Okay, and you have a week to figure out which ones you want to do. Okay, any questions about that? Okay. Again, what is a good project? A good project is one where you know what you're going to do, okay, and that you don't really see a, let's say, trivial roadblock to stopping you from doing it. A world like I can't find the data set, okay, is a roadblock, okay. Any questions about any of the projects or discussion or anything like that? From TV land or here. Okay, someone. Nothing. Okay. If you want, I'm available after class to talk. If people want to talk about their projects. But actually, generally, what I find is that there are general questions that most people could benefit from. What is the expectation from the the project proposal at this time? The sample project. I didn't see what the rest of the sample project thing said, but you know, it could be that again. I showed you what I thought were the best um, project proposals. If you go to my webpage, I gave you examples of project proposals. I put up the best ones that we had, okay? Um, Now, what is my expectation? My first expectation is it is 3 to 5 pages. That means not more than 5 pages. If it's more than 5 pages, I will be unhappy. Okay? I'm expecting you to have picked one of the topics with, enough of a discussion that when I read this, I should be, I should be convinced that you know kind of what direction you're going to go in. Okay? That's kind of the thing that's important to me. Where I am happy with a project is when they have picked one, they have their opening paragraph or two to show me that they know what the topic is. Maybe they've done some reading and they have some citations to things. Ideally, they have gotten access to a data set and done something to convince themselves they can open the data set and do something. Okay, so that because that's where there is the biggest initial unmovable roadblock if you don't have the data for it. Okay, and then I'd like a clear discussion, a discussion that shows that they've got ideas of what they are going to be doing. Does this mean that this is the direction they have to move later? No. Okay, can you change it on your progress report if you have better ideas? Yes. But I want there to be a direction to move, intended direction to move in, so that you know that what you have to do from there on. Any questions? Does that answer your question in TV land? Okay. Yes, good. Any other questions about the project? Okay. Any other questions about the homework? Okay, go ahead and beat on that, and we will look forward. The other thing that I will warn you about the project proposal is the vision is you will be turning it in a week from now. The vision will be that within 24 hours of that, you will be getting email with three links, presumably, to three proposals that you're supposed to peer review and look at. Okay? And when you get that, what are you going to do with it? Okay, you should read through the proposals. They will be on the general range of where you are. Maybe you will find these other people have interesting ideas. Maybe you will find that there's certain things that look weird to you that you would like to, maybe you can give them some help and give them some other directions. So that's what the peer reviewing is, okay? And in order to make sure that we, get you guys back to being able to work on your project, those peer reviewing will be done over next weekend. This weekend is writing the proposal, reading the three proposals, and getting back is a next weekend thing, okay? And that way we can turn around the feedback to you quickly enough you're able to get back and start working on your project again. That's the vision, okay? Any questions? We'll talk more about that, I guess, a week from now. Okay, any questions about homework or project proposal before I get going any further? Okay, we were talking about, we started talking about visualization, which is an important, I think a very important aspect of data science. And I think the examples that we had I showed, I believe it was last time, of what people put down for interesting graphs shows that there is a big difference between very effective visualizations and really visualizations that don't show anything. And learning how to make a good visualization is, I think, a really important thing, regardless of what you get to do. Some of you guys are going to go become data scientists. Others of you are going to become high-powered corporate executives and make presentations to other high-powered corporate executives. And you're going to need to look at, I think being able to look at at displaying information in a sensible way is a skill that is very, very worth developing. But one of the things that makes it hard is I think you've got to develop an aesthetic of what is a good visualization and what is a bad visualization. And, aesthetics come up a lot in art, let's say. Here I have on the screen two paintings from the Metropolitan Museum of Art. Okay? Does anyone recognize any of them? Here in TV land or here? Okay? Again, I encourage you guys to go to the Metropolitan Museum of Art in New York. It's one of the great art museums in the world. You will actually see me there once a month or so. I do like to go a lot because it's a very interesting place. These are two of the great paintings in the Met. The first one is The Death of Socrates by Jacques-Louis Davies. Okay, David? The one on the right is by, oh goodness, I think it's called Autumn Rhythm by Jackson Pollock. Okay? Jackson Pollock happens to have been a Long Islander, and in fact, his house is owned by Stony Brook. Okay? So it's out east in the Hamptons, and, maybe someday you should visit it. But first, visit the Met. Which painting do people like better? Okay, this is the main question I want to now ask you. I see there was a okay. Hold on, I'm not seeing as many comments on my screen. Okay, wait, hold on. Let me just get the chat going. Maybe I don't want participants. Close. Oh, okay. Okay, now I'm seeing more comments here. If we're going to choose physical retrieval patterns of objects, when can we get the data set? The TA, Tangier, has the data set and has the NDA form. So you should be able to correspond with Tangier to get that. Has anybody actually gotten that from him? Or are people blocking? Okay. So the answer is that should be available. I have given it to him. He should be able to, to work on that. Okay. Any questions? Any other questions about the project before I go on? Okay.
Around the same project, Professor, I wanted to ask that there are a lot of options that are given. So approximately how much are we expected to do in that?
Okay, how much are you expected to do? You're expected to do something interesting on the scale of what is a project. Okay, and I give you examples here. But there, I think the interesting question when we looked at that was, how well can you predict what order people are going to put things in a cart or put things through the scanner? Okay, and I give some suggestions as to ideas you might want to use to help figure that out. But that's up to you. Okay. Again, the final report will be 10 pages, I believe, was what I think the limit is. You have to check the syllabus, but that's probably what I tell you the limit is. So at the end of the semester, you want to fill 10 pages of stuff that is interesting enough, that is good. Do you have to do all the things I mentioned in there? No. Do you have to do many of them? Not necessarily. Do you have to do something reasonably well? The answer is yes. Okay, this is where using your judgment and coming up with your proposal of what you want to do is probably a good, a reasonable thing. That's one reason why I want to ask. If you have something in particular you're interested in, that is fine. That's what I kind of want you to specify what your direction is going to be on your proposal. Does that answer your question?
Yes.
Okay.
So we have to do the retrieval part of it. Like I read that you can do market basket analysis, or we
If
can
you
part
have
of them
something
written down.
else you want to do on that is not exactly what I'm asking, but is interesting and exciting, you can propose that.
All right.
And again, hopefully you've got a reason and stuff like that. There's no reason, but again, if that's what if you have an idea that you're driven by, go ahead and propose that. That I think is fine. Okay, and if you want to come and talk to me or something like that beforehand, I guess that's fine. Although, of course, again, I'll have my office hours after this. Any questions? Okay, but if you have a direction you want to go that isn't exactly what I say in there, go for it. Okay, but of course you're going to want to support it. Show that what explain why you want to do it. Show explain why it's interesting. Show that you can do it. Okay, and then I think you as peer reviewers should view that positively. Okay, any questions? Any other questions about the project? And congratulations to whoever to Hugo who knew who Jackson Pollock was. That's good. Okay, which one did people like better? Okay, did they like who liked the death of Socrates better? Okay, I'm seeing, okay, who here likes, what you call it, the Jackson Pollock better? Okay, I'm seeing only one Jackson Pollock fan, more David fans. Why did you like the Jackson Pollock? You're saying that the one on the right looks more intricate and that it took more effort than the one on the left. Now, many people might dispute the effort thing, but nonetheless, that's a perfectly fair opinion. Who here liked the Jacques Louis David one? Why did you like the Jacques Louis David one? Anyone? It's okay to like it. There's nothing wrong with that. Yeah. Okay. You say you like the characters, you like the realism, you may like the pathos. This is about Socrates right at the point where he's being given the hemlock, that he's going to drink and he's going to die. He's sentenced to death. These are the guys who gave it to him. He's surrounded by his philosopher friends and they're reacting to this thing. Okay? Which of these is better? Both of them are good. Okay? If you want to try to discuss which is better, you need a language, you need an aesthetic to talk about it. When I look at the Jackson Pollock, there is an incredible sense of energy in front of this painting. Okay, your eyes are following the loops going around and the drips and stuff like that. There is a tremendous sense of pathos and marvelous sense of realism in the Jacques Louis David one. Okay, you need a language to talk about what you like about art. Now, we're not going to be talking about art in here, but we are going to talk about mathematical graphics. And for this, if you wanted to talk what is good or bad or what you like or not like, okay, you need some kind of an aesthetic, okay, some tool for this thing. And my personal aesthetic for scientific visualization comes from the books of a guy named Edward Tufte. Here's one of them. I have 3 of his books. I saw the other day he's up to 5 of them. But these are books about mathematical graphics where he shows good ones and bad ones. And, with some kind of a philosophy of what makes something good or bad. Okay? And my feeling is these are about the best books I have ever discovered for sitting on the toilet with. Because they have little pictures, you're looking at them, that you can open up anywhere and start to look, and very interesting thing. And he has a bunch of principles that I think are worth thinking about when you see graphics. Okay, he will talk about maximizing data ink ratio. He will talk about minimizing the lie factor of a graphic. And he will talk about minimizing chart junk. Okay? And so I think learning to think of graphics in terms of these gives you an idea of what is good and what is bad. Any questions? There's, of course, all kinds of other criteria of, let's say, mechanical things that you need to do. You need to use proper scales. You need to use clear labeling. But it gives you a way to think about graphics, and that's what I'd like to talk about today, and maybe a little bit more. So what is the idea of data ink ratio? In a mathematical graphic, okay, he defines the data ink ratio conceptually as being the fraction of ink that is devoted to showing data divided by the total ink in the graphic. And here he is showing, two plots of the same data. Okay, it breaks down, I guess, maybe it's SAT score or God knows what, by whether people are male or female and what their income is. Okay, and you see these two bar charts that you see here. Which one of these do we like better? Okay, and this is your first aesthetic. The one on the left or the one on the right? Who likes the one on the left better? This one. Why do you like it? Looks more what?
Looks more appealing.
It says looks more appealing. You like the shadow? You like the drama of the three-dimensional bars?
Yeah.
You may like the receding perspective going into the thing. Okay. Would Steven Spielberg like this one better than that? I don't know. This is one of these date myself. Who here knows who Steven Spielberg is? He was the director of various movies, so but that's probably dating me. Okay, who likes the one on the right better? I'm seeing most of the people here seem to like this one better. Why do you like that one better on the right?
Because you can read the data. Because you can interpret the data easily.
You're claiming it's easier to interpret the data. Why is it easier to interpret the data?
Because we don't know where exactly the path lies. We have to imagine.
You're saying that as this thing recedes, it's harder to know what that number actually is, right? Does everybody see that among the graphic effects here, as this thing recedes in the distance, it's going to get smaller. What is the actual value of this number? When you have the simple 2D bar chart, the numbers are easily read, okay? Tufte would say this one is the good one and this is the bad one. Why? Tufte wants to maximize the data ink ratio. What good does the shadow do? The shadow may provide some aesthetic, but the shadow doesn't tell you anything about your data. What good does the three-dimensional bars do? They don't tell you anything about your data. What good is the, kind of fading off into the distance? Well, it's good for showing off the three dimensions in the shadow, okay? But for showing the data, it's only going to mislead. That's actually more like the lie factor, okay? So this is the one that we would vote to here. It's in terms of easiest to interpret and stuff like that. Any questions? Okay. Fair enough. A second criteria that Tufte would talk about, like I said, is the lie factor. The lie factor is kind of conceptually the size of what you're seeing in the graphic divided by the size of what's really kind of being shown in the data. Okay? And let's look at this figure. This is a cartoon here. Okay? If you'll notice, what is this doing? It's showing what's the percentage of doctors in family practice over 3 years. What is the effect that you're seeing? The size of the doctor is presumably supposed to correspond to what fraction of doctors were in private practice. What is the story being told by this graphic? Okay, did the audio get worse? Actually, is that true for people back there? In TV land, is my audio okay? It got better again. Okay, good. Okay, what's the story being told here by this graphic? Again, a good mathematical graphic will tell you a story. That's what you want to see when the data is. Look at the data. What's the story? What's the story here? Does anyone have a sense of the story? Okay, to me the story is, my God, okay, private practice is going away. Okay? What you call it? That at one point you had a huge number of doctors in private practice, and now you've got a tiny number in there, right? That's what it's showing you. What does the data show, though? This shows that there were, what you call 8,000 doctors before, okay, in private practice. Now there's 6,000. Okay, that's a decline, but it's nowhere near as big a decline as you see with the people. Okay, now here it says 1 in 2,000 were relative to the population. 1 in 4,000 relative to the population. What's the decrease in the data? Okay, if we look at the proportion from one in 2,000 to 1 in 4,000, that's about half. Does this doctor look half as big as this doctor or not? You guys can look at that. Who here thinks this doctor on the right is half the size of the doctor on the left? See a couple. Who here thinks that he's smaller than half? I think he looks a lot smaller than half. Actually, nobody's agreeing with me. What is probably a half is the height. I can believe that the height of the doctor from here to here is 1/2 that of this. Do I believe that? The answer is yes. But what's the area of the doctor? Remember, area is a two-dimensional thing. And when you're looking at this, you're probably thinking of seeing area and not height. The area of this guy is probably 3 or 4 times bigger than the area of that guy. Okay, and that's what Tufte would call a lie factor. Okay, when you represent a two-dimensional area or three-dimensional representation of one parameter, presumably, you should be normalizing by area or volume rather than length. Okay, or maybe you should be avoiding that in the first place. Any questions? On the right, do we see a lie factor? What is the story of this graphic? This is about the price of oil. Okay? What is the thing on the graphic that you're seeing? They give you numbers, okay, of what the price of the oil is. What is the visual effect of, let's say, comparing the second barrel to the 1979 barrel? It looks to me like, my God, the price of the oil has absolutely gone crazy, right? But what's the difference? Here oil was $10 a barrel. Here oil was $13 a barrel. The size of the barrels does not really in a meaningful way correlate with the bar chart, right? And the perception you're getting is, my God, the oil price has gone crazy. Any questions? That's what we mean by a lie factor. Part of what goes into having a lie factor is, making sure that that again, you want the data and the message conveyed by the graphic to, to kind of show the same thing. The one on the left is from a TV news station that is showing you what's going to happen if the tax cuts expire. What's going to happen to the tax rate? What does it show? What do you see on the figure on the left? Okay, this is what the tax rates are now. This is what they're going to do if they let that tax cut expire. What is the effect of the graphic? What is the story that it's telling? Yeah? It looks huge, and my God, and the world is coming to an end, right? What was the change in the tax cut? This said it was 35%. Now the rate's going to go to 39.6%. Okay? If you plot the full bar chart, this is what you get of those numbers, right? Here, they did give you a scale, but they didn't start the bar chart at 0 the way it should. If you start the bar chart at 0, you get the real perception. Are taxes going up? Yes, they're going up. Is it the end of the world as we know it? The answer is no. Okay? And this is kind of to kind of make sure that your graphic tells the same story as reality. You almost always want to start the scale at 0. You want to make sure you properly label what your axes are. And you want to use what I would call continuous scales. Okay? You want to make sure that you don't, sometimes people will do things like they'll have a break in the bar. Okay? And that's bad because then it's hard to see the real size of what you're looking at. Any questions about that? So when you look at a graphic, you should be looking at, is this graphic telling me an interesting story? And does this story really reflect the data? Any questions? Here are 3 different plots of company sales as a function of time. Okay? What is the message given by this data? What is the message given by this plot? What has happened to sales? What? Plummeted down. What is the message of this chart over here? It's even worse. The world has come to an end for this company, right? What is the message of this plot at the bottom? What do you see? How's the company doing? What? Doing fine. It's had a bad month. It's not a big deal. What is the important point? For all of these, you're seeing exactly the same data. Okay? Let me try to set this thing up. No, it's not that one. For all of these, you're seeing exactly the same data. Okay? And yet the perception is quite different. That's what we mean by a lie factor. If the perception is not matching what we're really seeing. Now, which one of these would be best if you wanted to capture a true representation? It's a little hard to tell, but people are used to seeing charts with this kind of aspect ratio. This is kind of the golden ratio. You're used to seeing rectangles like that. Your TV looks like that, okay? Jacques-Louis David's painting of Socrates looks like that, okay? And since people are used to viewing that, that kind of, chart, presumably that's the most interpretable one. We should be aware that different effects can be given by a graph depending upon how you scale it, okay? And you got to make sure that, therefore you have an intellectual and moral reason to pick this carefully. Any questions? There's all kinds of other good examples in Tufte's books. This is one of my favorites. This was plotting how, the fuel economy standards. Remember, the United States has a law that says that new cars have to have a certain level of fuel economy, miles per gallon. What does this figure on the left show? Okay? It's a graph. The axis over here is year. The axis over here is the, what you call it, the miles per gallon that's required. What is the message of this graphic? Says, my God, they're out of control, right? The fuel standards are growing. It used to be this big, and now it is this big. Okay? But on the right, we have an actual normal plot. Okay? And the difference between this big and this big is the difference from here to here. Okay? So again, what you have is a world where, you know, you can quantify the life factor. The real difference from here to here is maybe 40% or something like that. The real difference in the length is something like 5 or 6 times. Okay? And that's what we mean by a line. Any questions? I think that's good in principle. Okay? The other dimension in which Tufte would talk about trying to design a good chart is trying to reduce what he calls chart junk. Chart junk is this idea of kind of visual elements that, you know, kind of may look pretty, but that they're not really conveying, you know, new insight about the data. Okay, they're more artistic decoration. Okay, the things like they could be decoration, they could be heavy grids, they could be more colors than are necessary. Okay, they could be adding dimensionality where you don't have it. Okay, and you know, again, the principle of mathematical graphics, if you believe in Edward Tufte, is that what you call it, the data needs to tell the story, not the chart jump. So let's take a look at some examples of chart jump. First of all, the inspiration is this. Has anybody ever seen, does anybody know what this building on the right is? Any Long Islanders who have known, what is it?
Oh, I've seen it on News 12.
Seen it on News 12. You go out, I think it's in Flanders, okay? This is a building that is famous. It's the Duck. What is the Duck? It used to sell duck eggs, okay? And what was it? So they built in this little egg stand. They built the building so it looked like a duck, okay? Does the duck have a functional value to it? The answer is no. Well, no. I guess if you're trying to sell duck eggs, yes, maybe. But it's clearly something that is not a functional thing. It is sort of an added visual element that doesn't really belong there. And so Tufte will talk about graphical ducks, things that they add to the function of something to kind of make it look better, but maybe not obscure it. Now, the figure on the left, okay, what is it showing? It is showing that the data of, it's showing that over a 5-year period, what is the fraction of students going to college that are age 25 and over or under 25? Okay, so you guys have been to college, you have a gross sense of how people are aged. Okay, the x-axis is years, the y-axis is a percentage of students. Okay, and this is the ones that are less than or equal to, this is the ones that are greater than or equal to the fraction that are greater than or equal to 25, and this is less than or equal to 25. Do people understand what the great data being shown here is? What in the way of graphical elements here are seemingly not necessary to helping you understand it? Is there a way that we can simplify this graphic to get the point across that it's trying to make? Okay. What weird things are going on here? First of all, how many data points are there? There are a total of 1, 2, 3, 4, 5 data points. Does everybody agree with that? Are these data points up here? That's the fraction that's under 25. This is the fraction that's over 25. Is there any data at all in the top part of this thing? Yes or no? Someone with a hand. Okay, or a mouth, okay? I claim that there is no data at all up here, okay? Why? If I know what percentage of you are male, do I know what percentage of you are female? The answer is 100 minus, in the traditional world, 100 minus that, right? Okay? So all this is unnecessary. Now take a look at this. Are there things here that are not helping you see the data from the 5 points? Are there extraneous things that are going on? Or does this look like this below would be a good graphic? Do we have some chart junk? What chart junk do we have? What 3D? Why do we need the blue colored part? That just goes off. Let's get rid of the blue part. Is there any other chart junk going on then? Now let's say we got rid of the top. Let's just say we got rid of the blue. Is there anything else weird about this plot? Yeah? You'll notice that from here to here we got a curve. Here it goes straight up. There is an underhanded curve, right? Okay? Then there's another underhanded curve. What does that mean? First of all, it makes it look continuous. And you're saying the data is not continuous. Well, on some level it might be continuous. Is there at any given moment a fraction of men and women in college? And does it change from day to day? Any one of you drop out of college, it's going to change, right? So you might say, well, maybe it's continuous, okay? And that might be an argument for connecting it with a line. But why are they fitting it with these weird curves? Okay? What the weird curves are showing is simply that the artist was having fun with that, right? And that if you had a graph that looked like this, it would be wildly more informative. Okay, there would be nothing to mislead you. Chart junk, when it's bad, misleads you. In fact, now if you go to the big duck, you won't be able to get duck eggs. You'll be able to get information about Long Island tourism. So you're going to even think that the duck is misleading you now. If you go there, you'll be disappointed looking for duck eggs. So there's an art for trying to look at plots and simplify them. Okay, if we think about what chart junk is about too much, too much in the way of things that are not data ink. We like the idea of increasing data ink. We like the idea of removing things that are on our graph that are not data ink, that are there for, well, why are they there? Does anybody have an idea of things that can be removed from this plot? This is showing sales. I guess maybe it was showing interest rate over a month or a percentage of sales in some category in 1 month. How can we simplify this graphic? What? You don't like the grid lines. Okay, woof, they're gone. Okay? Now, is there any other data ink here that can make this better? What? You don't like the background? Woof, it's gone. Okay? Now, is there anything else that you can remove that is not data ink? Okay? The gray lines on the right You mean you don't like, okay, you don't like, I don't think you like, tell me you don't like this, I think, and you don't like the gray lines, that might be the ticks. Woof, they're gone. Is there anything else we can remove here that would make for a better graphic? Or are we down to only data ink? Okay. Well, what if I remove some of the ink from my bars and now have show where my grid lines are? This is removed, has even less ink, but it's conveying more information in some sense. I can now read off the numbers much more precisely than I did before. Okay? So to me, this is actually, it shows how we have greatly simplified the plot. Okay? And I think this is a better representation than any of the others. People can have some debate about that. But again, the principle is we want to remove non-data ink. We want to remove visual elements that aren't helping us interpret the data. Okay? And that makes a better graphic in general. Any questions about that? Okay, and again, this is one that we can push back on because the debate of which art is better is a somewhat subjective matter. It's okay to have somewhat different opinions. Okay? But it's also important to have an educated view that you're reasoning. No, why am I adding this chart junk or not? Okay? I think that's a good aesthetic here. And you may say, oh my God, but if I want to do all these things, isn't it complicated? You guys in Python are using the matplotlib library, I assume. Are people familiar with that? And again, there's lots of plots. There's plots that do all the things that it's easy to make plots that do all the things that I did there before. Okay? So this is not, part of it is a question of understanding what the judgment is and understanding what the options are and having an aesthetic of what do I want to have happen, what don't I want to have happen. Any questions? Okay. Now, there's a plot in my book, and one which I reproduce here, which is kind of cool, which is which chart do you use to show your data? And depending upon what you're trying to show in your data, there are different kinds of mathematical graphics that you might want to do. If you want to show a relationship between two variables, maybe you show a scatter plot. If you have more than 3 dimensions, you can show a bubble plot. We'll talk about them later. If you want to show a distribution, you can use column histograms, you can use line histograms. You might be able to use scatter plots if it's 2 dimensions. You can use area charts or stacked area charts sometimes. Okay? So recognize that there are a bunch of different kind of graphics. There are different kinds of line plots with multiple lines, single lines. There's all kinds of, there's pie charts and bar charts and things like that. These things exist for reasons, and it's important to kind of have some idea of what the suite of options that you can have. And, pick a representation that is going to show your data to the most useful way to do it. So we're going to go now over some of these plot types to try to get some sense as to when they're useful, when they're not, how do you make them good. One type of data representation that is not graphic, but still can be incredibly informative are tables. Okay, if you have a tabular data, okay, you can have, sometimes tabular data is better than showing a graph. Why? Well, one is you can show exact numbers, so you can capture precision that is there. Okay? You can encode many, many dimensions, okay, in a table. If you think about it, if you have n items here and m columns, from 1 to m, that's really showing m-dimensional data. Tables can show things in, 5, 6, 10 dimensions. And, normally the eye has a hard time understanding it. You can represent things that are not necessarily numerical data. Okay? If something is Boolean, you can show it as true or false in a table. You can have a name. Okay? And if you've got a small number of rows, tables can be very compact. So here's an example of a data table. This shows various sort of demographic data on countries. Okay, it lists, I guess, it looks like it's about 10, 15 countries. It has 1, 2, 3, 4, 5, 6 dimensions numerically of stuff. You've seen and made tables like this before, but let's think if we want to make a table that is going to be read, convey as much information now. Are there ways that we can improve this table? See what I've got here on the screen. Is there a way that this table can be improved? Okay, convey more information, make it easier to see what's going on. Okay? Are there any changes people can suggest, or degrees of freedom we have to maybe show something different? Or do people like this table? Yeah? Okay, so you're saying that you want to use metric data. Okay, you're saying I believe in hectares for area. I don't believe in acres or square miles or something. This table doesn't specify what the area is. Probably I should have specified the unit at least. So if I said that this was square miles, that probably would be informative. I'll give you that much, okay? Is there anything else I can do to this table to make it better? Yeah? Sort. So I do have the freedom to rearrange my rows, don't I? Okay? That's what you see on the TV as well. What column would be interesting? Recognize that there's several ways that I could sort it. What should I sort it by? You say population. I could sort it by population. If you want to show off population differences, then sorting it by population is meaningful. But if I want to show something different about GDP, sorting it by population would obscure it, right? So I certainly could sort by any one of these columns. Is there any other way I could sort it? I could sort it by the country name. What would be the advantages or meaning of sorting it by country name? It becomes easier to look up, and it shows that there's no other inherent order to this thing, right? So if I'm just trying to scan at the Gestalt, if they're sorted by countries, I know there is no meaningful order. Here I'm saying, why does Russia put first? Did Vladimir Putin make this table up? Why is this table ordered like this? I have the freedom to rearrange the rows. Anything else I can do to make this a better graphic? Or this is still done? Okay. I personally see several things I don't like still about this table. Anybody want to have any other things they don't like? What?
Change it to another, like touch on the numbers, it's like something or larger number. Something like 1.4K, 14 billion, something like that.
Okay, so one question that you're saying is, you don't like that I have big numbers here. Okay? You're saying I could write it in scientific notation. That's one thing you're saying. And maybe you like scientific notation. Scientific notation, if you can read it, the number of exponents is good. Okay? One thing that's lost with scientific notation is the precision of the data. The fact is that this guy, if this was written as 1.42 times 10 to the 7th or something like that, okay, you lose track that it's precise. Okay, maybe you could use scientific notation. Is there anything else you could do though to capture the to better capture the relative sizes of these numbers. What? You might color them, yeah. One thing that's a big sin here is the numbers are not right justified. So why is it that you're having trouble seeing which is big and which is small? Well, look here at little China, okay? China, of course, is a big population. It's hard for me to tell that China is bigger than Russia because they're all starting in the same place, right? If I had them right justified, they would be reflective of how big the population is, right? Anything else I can do with these numbers? Yeah? Okay, I'm not sure I'm not hearing that or getting that. Try it one more time.
I think if the all number in one column have the same significant number.
Okay, so there's questions of all the numbers have the same significant digits. One thing that you're concerned with is, do all the numbers have the same significant digits? Okay? It should be the case that they all do. Now, these all are integers, end in 2 digits, 1 digit, decimal digit, integer, 2 decimal digits. Oh, wait a second. This thing does not have two digits, right? We probably should unify the length, especially if we're going to right justify them, right? So that seems like an important thing to do. Is there anything else to be done to improve these numbers? Yeah? One possibility is, one reason I have a hard time dealing with this is I'm not used to, I don't have commas or separators. If I had a ka-chunk, 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 I see China's got billions. And Russia, ka-chunk, ka-chunk, only 142 million, right? So I would understand that much better if I had commas in there. Anything else that I would do? Are there any other degrees of freedom here? Yeah? The GDP is all listed as integers. Why do I have these zeros there? Okay? So what I should do is, if I'm smart, I don't see any reason why I should have that there, right? Is there any other degree of freedom? The other degree of freedom that I can think of is I could reorder some of the columns, right? Sorting was to reorder the rows. But what if I reorder the columns? Is there any sense that some of these statistics would be easier to compare if they were next to each other? What? You think that area and population, maybe population belongs, I don't know, maybe between area and density. Okay? And birth rate probably belongs next to mortality, right? It's like input and output type of thing. You know, so you have that degree of freedom. So again, we have the ability to do all these things. We have the ability to add emphasis. One dumb thing I see on a lot of student tables is that they will instead say, instead of GDP, they might have written gross domestic product. Okay? And what does that mean? That means that there's going to be a giant entry with all that white space in there, right? So making sure that you have descriptive, but not overwhelming things. Maybe you should stack that. Gross domestic product. That, on the other hand, might make sense. Okay? Uh-oh, am I now in trouble? Hold it. Boom. And so this was my improved table. What did I do? I happened to have sorted it by, what you call it, alphabetically. I added my comma separators. I also highlighted in bold what was the biggest of the things here. And this now, I want to look at this and tell me a story. What do I learn? My God, China really is a big country. And my God, Russia really has a lot of space to it. And my God, I don't want to be in Afghanistan. Okay? And yes, the US is considered rich by this data. But that's funny. Australia, I didn't realize Australia had the highest birth rate. Okay? So that's the kind of story that you would like to be able to tell. That if you think about your graphic, okay, you can see it and it can tell it that very well. Any questions? Part of this is dumb, and you're saying, go, teach me something that has math in it. But part of me says that understanding this aesthetic is important to try to present data well. Okay? What's another thing? Often people will represent line charts where you have y as a function of x. Okay? Recognize that there are different ways of doing this. Here is one where we're using a polyline, okay, for representing the thing between data. Here is one where we're representing a polyline, but not seeing the points. Here is one where we're seeing the points, but not seeing a polyline. We're seeing a trend, some kind of fitted thing. Okay? Which of these three is best? Well, it depends. Okay? What are the advantages and disadvantages of this one? Here, I'm seeing trends. If I have a lot of data points, maybe, again, if this was like daily data, okay, it might be distracting to show the individual points. That might have been the decision that they made up there. This one, they're showing the polyline, which is usually the default that people do. Sometimes the polyline, I think, causes artifacts, visual artifacts that are harder to tell. What do you see when you look at the polyline? My God, look at that sudden drop. My God, look at that sudden drop. If, on the other hand, you had a trend line, a lot of what looks like the big moves are really kind of just probably noise. Okay? So, often, not always, but often connecting points by lines is chart jump. Okay? I generally like the idea of showing a trend line and the actual data points. If you just show me the trend line, I don't know what you're hiding. If you show me the trend line and the actual data points, I can get to myself what is the story that's being shown, how erratic, how good is the fit, stuff like that. Any questions? Okay, that's my feeling on line charts. There are also scatter plots. Scatter plots kind of show the value of data points, okay, where you want to have individual values. And in 2D, scatter plots are really nice. People often try to generalize them to higher dimensions, okay? But, using bubble plots, which I'll show you in a second. But sometimes the bubble plots are distracting, and there might be other ways of showing your higher dimensional points in 2 dimensions, using a technique like self-organizing maps or principal component analysis, which we'll talk later in the course. So this is a scatter plot. It shows there's X and Y values. Each dot represents an individual. Perhaps X is weight. Perhaps Y is height. This is a scatter plot. What is wrong, or what could be done to improve this scatter plot on the left? This is a typical scatter plot. Are people happy with that scatter plot? What can you do to make it better? One thing that I almost always say, I'm sure I will say if I see your project, okay, is make the dots smaller. If you have a lot of data, what's the advantage of showing the smaller dots? Here, everything is overwriting everything else, and you don't really get the sense of where the points are. Here, I get the sense that yes, there is a tight core where most of the points are, but I can start to see how the distribution fades away. Any questions? Okay, so don't be afraid to make the dots smaller. What else do I think is bad? It would be good to have a title on the graph, so I knew what it was, and labels for that. But I guess scatter plots are good things, but don't make the dots too big. Any questions? You know, a more advanced form of a scatter plot is something called a heat map. Here is a plot of people in America by height and weight. Okay? And one thing that's true is, I am actually, let's say 161 pounds, and I'm 5'8". Am I the only one in America that is 5'8" and 161 pounds? Probably not, right? If you draw points like this, you're often going to have points stepping on other points. This is a problem. If I have integer values on things, can I solve the problem of points overlapping each other by making the dots smaller? The answer is no, because two people with the exact same height and weight are going to overlap each other. So if I really want, though, is some way to kind of show me where the points are and what the frequencies are. Sometimes people do that by making dot plots where they have some transparency on the points. So that if you have 2 points over each other, it shows up as darker. Another way to do it that's generally better is to use a heat map where the number of values at each point, okay, are shown in different colors. We've got some kind of a color scale. And when you look at this, you say, where are the people in America really living? This seems to be where they really are. That's what the average American is like, right? And you see what outliers there are. And you see a lot more with the heat map. You get a much better sense of the structure of what your data is. Any questions? To make use of a heat map, you need to have enough data points there. But what's great about a really good mathematical graphic is it will show you all kinds of data with, show you a tremendous amount of data on one slide, and you can really understand what's going on. Now, there also are bubble charts, are a way of representing higher dimensions. In a scatter plot, you had an XY graph, okay? And that was showing basically the relationship between two variables. In a scatter plot, we show other things, okay, by using color, or by using the size of a dot, or even the shape of the dot. What is this showing us? This is showing 4 different dimensions on every country in the world. The x-axis is how rich it is. The y-axis is what the life expectancy is. The size is what the population is, okay? And the color is what part of the world is it. I gather Asia is red, Or I guess there's a difference between red and blue is East Asia versus, West Asia, okay? What do you see when you look at this plot? This is a great plot. This is 4 dimensions of data. What are the lessons? What's the story being told here? Can anyone tell me a story about countries and health and wealth and size and everything like that? What are your impressions when you see this? Is there a story that's being told? Someone see any story? Yeah?
Basically, the countries which are to the right are have more GDP and which are has more life.
Life expectancy, you can buy can buy health to a certain extent, right? That's what you're saying, because life expectancy is going up with wealth. That's fine. What else do you see here? Bubble size is population. What do you see here? I mean, when I look at that, that tells me, well, the biggest countries in the world at that time, this is 2010 data, they look like they're kind of stuck in the middle, both health-wise and money-wise, right? What else do you see here? Yeah? You see that money is not uniformly distributed. The African countries are poor, generally. The Western countries, okay, are generally relatively wealthy, right? That's one thing you see here. Are there any other things that stand out about this graphic? Which countries are doing unusually badly? Okay? You take a look at it. What country is doing well? What country is doing badly? What? Zimbabwe. What's Zimbabwe? Well, Zimbabwe does not look like a good place to live. Okay, it's poor and people die there. But it looks like that's the same on both. Are there any other countries doing unusually well or unusually badly? South Africa is a kind of an outlier. It is quite wealthy, but people don't live very long. Why is that? Probably the wealth isn't spread very fairly there, is it? Okay? Are there any other countries that look like they're outliers in this? That's why I like to look at these kind of graphics. What other countries are outliers? Japan? Well, Japan is clearly the one that is not the richest, but lives the longest. Okay? That's one thing that's interesting about Japan. Any other countries look like outliers? Okay? When I look at this, I say, well, Russia is fairly wealthy, but those people die young. And I look at Cuba and said Cuba is poor, but their people seem to do pretty well. Okay? I encourage you, I'm not going to go over it, but I encourage you guys to check out the video here. It's a nice story where he looks at this over time. And it makes it now a 5-dimensional data thing because he's going to show this thing over time. And you see how the history of the world has changed. So I encourage you to check out that link. Any questions? Okay, what other graphic things can I tell you about? One thing that people often use are pie charts. Okay, and let's look at pie charts versus bar charts. This is showing 3 years, okay, of presumably sales into 3 different categories. Okay, a pie chart uses the space or the area is going to be is the fraction of the circle. It's proportional to that variable. Okay, on a bar chart we have what you call it, the number written out, and the aggregate is the size here. What do people like about bar charts? What do people not like about bar charts? Okay. One thing is bar charts use more area than other data representations. So if you have a small amount of data in there, maybe a bar chart, pie charts are kind of excessive. The pie chart is good at showing you the breakdown of what fraction is in what versus another, the size of the pie. Okay? But it doesn't show you absolute magnitude. In the bar charts, the relative fraction is the size of the bar, the proportion of the bar that's each color. The total amount, though, is also conveyed by the bar charts. You can't really get a sense that in 2004 the pie was a lot smaller than 2006 from just looking at the pie charts. Does everybody agree? You might scale the disk down, but the disk, remember, is a two-dimensional thing, and it probably won't capture that accurately. Okay, there'll be a lie factor associated with that. Tufte hates pie charts. Okay, you know that there was on the TA who took my class before, when he computed what fraction of people were doing what project and posted that on Piazza. He apologized for using a pie chart because he knew I didn't like them. But that was a good use of a pie chart. There were 7 or 8 classes. They were all pretty large. Okay, you could get a sense of it. That was a good use of a pie chart. Not all things are good uses of pie charts. Which one of these pie charts is better? Okay, these represent what fraction of the vote Trump got in the primary at one point. Okay, which pie chart do people like better? Do they like the one on the left or the one on the right? Certainly, if we believe in Edward Tufte would like the one on the left. Okay, notice on the right, where do we see chart junk? We see chart junk in the 2 dimensions. Okay, we see chart junk in the tilt. Notice the tilt warps the area. When you look at this, Cruz looks like he's a really unbelievable, right? In this one, do I think Cruz looks bigger than Trump? You know, it looks pretty close, right? On the right one, there's the truth. There's a reason why he was president and he wasn't, okay? And it's because the pie chart was better interpreted flat. What is the value of separating the slices of pie? What was the value there? It better showed off the 3-dimensional effect, okay? But it didn't do anything to tell about the data. Any questions? So I'm going to encourage you when you do your projects and your homework to think about what data representations are good. I'm going to talk more about this next class. But in the meantime, do your homework, get your project proposal done, and we will talk about things. So thanks a lot. Okay, take care. Bye-bye.
Professor,
Yes.
are you gonna hold your office hour like later?
I'm going to hold my office hour. I'm going to, as soon as I get out of this room, I'm going to get up to my office and I'm going to turn on the office hour.
All right,
Okay?
thank you.
And
So
I'm
yeah,
not physically if you want to come in.
guys. So we'll just wait in the the Google meeting room, right?
Wait in the meeting room if you wish. Yes.
All right, thank you.
Okay, bye-bye.